Alright, in this tutorial we're going to go over some special cases on how to multiply two binomials together. You can think of these as some shortcuts for some specific cases instead of having to FOIL them together or to box method, which you still can, but if you know these special shortcuts, it could make your life a little bit easier, finish the problems a little bit quicker. So here we go. Your first example is if you have a binomial where two terms are being added together and you're multiplying it times the exact same thing. That's what this, when you square something, that's what you're doing. So you're taking your a plus your b and you're multiplying it times your a plus your b. Now your a and your b can be anything, but the key here is that your two terms are being added together in both of your binomials. So when you have two identical binomials that are being added together and they get multiplied, this is what you get. Your first term is squared. If it's an x, it becomes x squared. If it's 5y, it becomes 25y squared. Whatever the first term is, you just square it. Your second term is you're going to take 2 times your first term times your second term. Because this middle area, whenever you're FOILing or using your box method, is where you're multiplying your outers and your inners, and then you get common terms and you're adding them together. This is what the reduced form of your combined terms is going to equal. Then your final term is just the second term squared. Again, if it's a 3, it becomes 9. If it's 12, it's 144. Whatever it is, you just got to make sure that you square it. For your second special case is the exact same thing, but they're being subtracted. So a minus b times a minus b. It's the exact same thing. Funny enough, it's very, very similar to your first example. So your first one is still the same. The only thing that's different so far is now that is minus 2 times your first times your second. And this is still plus b squared. The reason why it's plus is because when you multiply a negative times a negative, you end up with a positive. But in the middle area, you're adding some positives in your negatives, and it will be negative in your middle term. For your last one is if you're multiplying the same terms, but the only difference is that they are being added for the first one or subtracted for the second one, or vice versa. It could be subtract first and then addition next, but it's that they're the same thing. This one is going to have fewer terms, so you're going to take your first term and square it, and then you're going to subtract your second term and square it. Because these are being adding and subtracting, they're going to be negative identities, so you would eventually end up with your middle terms of a -4 and a +4, those combine together to cancel out and equal 0, to where that you're left with just the first and the second terms squared, separated by a subtraction problem. So let's use these shortcuts into our first example. If you notice that we have a 4d minus 2 and a 4d plus 2, they're the exact same terms, but the only thing different is that one's addition, one's subtraction. So this is our third case right here, which means all that we have to do is take our first term and square it, subtract our second term and square it. So the square goes to both. 4 squared is 16, and d squared is d squared. 2 squared is 4. Now for the second one, it's your first case because it's the exact same terms that are being added together. So we have to take our first term, square it. Then we have to take 2 times our first term times our second term. And then we have to take our last term and square it. So 2q squared becomes 4q squared. Then when we multiply 2 times 2 times 4, that gives us 16, and we still have the q. Then at the end, we have 4 squared, which is 16. Now, knowing these special cases does make it a little bit easier to finish these problems. As you notice, it did not take me as long to finish these as is in the last section. But if you ever are caught in a jam and you don't remember, you can always use your same box method or your same FOILing methods to solve these multiplying of two binomials.